Good evening. How's everybody doing tonight? Good. My name is Reed Corbett. I'm the Executive Director here at the Coastal Studies Institute, and we certainly appreciate you coming out this evening to join us for our monthly Science on the Sound. I've got a couple announcements, very important to you, not as important to Sid, before I introduce Sid. And so the Science on the Sound series, many of you know and have been here for several of those. It's something we are trying to continue to do monthly. I just secured our February speaker, so thank you, Sean. And we do hope to continue these throughout the spring, so look for those announcements. It's typically the third Thursday of the month at 6 p.m., obviously here at the Coastal Studies Institute. And so yeah, continue to look for those. I wanted to let you know that all right, maybe your kids, some of your grandkids, our youth camps are going to take place again this summer. Those sort of, you can make your reservations starting March 1st. They typically fill quickly, so now you've got a leg up, you know, March 1st at 9 a.m. Is that right, John? 9 a.m. Midnight? Yeah, so if you want to stay up. That's funny. The other thing, and so we also have a newsletter that we put out about 3 times a year. It's a great way of seeing the different work that's being done by faculty and staff here at the Coastal Studies Institute, introduced to some of our interns as well as some of our students. And so look for that. My guess is in the next couple of weeks that'll come out as well. If you aren't already sort of signed up for that, on the main page of our website, you can sign up to receive our newsletter. It is online, but it's usually a very good read. And again, it sort of opens a window into some of the things that we're doing here at CSI. And then sort of the last announcement, I just want to make you aware that actually this year, 2023, is a big anniversary for us here at the Coastal Studies Institute. This is the 20th year in July of our founding. And so CSI has been here and engaged in the community for almost 20 years come July. And it's also the 10th year that we've been on this campus. And CSI has been growing a lot over the last many years and has really tried to make an impact on the Outer Banks. And so I sort of point this out, happy birthday to us, but also that we're currently planning an event. We always have an open house, and so we're planning on sort of combining an open house with an anniversary celebration, so also look for that. And with that, I'll introduce our speaker, Dr. Sid Narayan. Dr. Narayan, although does hail from India, did do a lot of his education sort of in Europe and the Netherlands. He did his master's in coastal engineering and management, and then moved on to the UK, University of Southampton, and did work, again, sort of engineering work, coastal modeling work in the UK, getting his PhD. From there, he moved on to the west coast of the US and spent some time at University of California, Santa Barbara, and Santa Cruz before we were able to pluck him from the West Coast and drag him as far away from that as you possibly can and stay in the US. And Sid arrived here at the Coastal Studies Institute in January of 2020, so another anniversary. If you remember that spring of 2020, there was something else that happened, I'm not sure what. A great invite to a very remote place. Let's send them virtual. And so anyway, we're very thrilled to get Sid here. I think this is Sid's first Science on the Sound. And Sid is an assistant professor in the Department of Coastal Studies, resides here on the Outer Banks, does research on the Outer Banks and around the globe, and some of that you will hear about today. Thanks,
Thank you,
Sid.
Reed. Thank you. And thank you all. Oh. All right, I think I should stop with that and leave on a high note. Thank you. Thank you all for being here. Thank you to Reed and to CSI for this opportunity, John, Blake, Parker for making sure everything works. Talking off, can you hear me okay, John? Okay, all good, super. So yes, I'm originally from India, and like Reed said, I've been living in coastlines all over the world. Last on the West Coast, and Santa Cruz, funnily enough, is exactly the same latitude as here, so it's literally just across the country. And most of my work has been on today's topic, which is going to be the role that ecosystems, coastal ecosystems, play in protecting people and communities from coastal hazards. Forces of Nature was inspired by the title of a report that we were working on in Jamaica, looking at mangroves and how they help reduce hurricane storm surges. It's two sort of forces of nature that are interacting to our benefit, and that's what I'll be going through today. So my background is, if you look at this here, is mostly engineering. And you'll see coastal, nature, modeling, nature-based solutions. So essentially, as an engineer, even though I call myself an academic engineer, I'm not out there building roads or building bridges or building seawalls. What I am doing is using engineering approaches to study all of these. And a lot of what I study is how flooding happens and how people can adapt to flooding and how they can reduce that using computer models and other tools, and specifically looking at the issue of nature's role in this. I'm really fortunate to be here. You have a beautiful view of the Outer Banks outside, not right now, but if you are here during the day, you'll see that it's a really incredible setting to work in, to be in, because it's really it's really the center of, a lot of coastal and tidal action here. And also living, while I do that, the barrier island life. This is not the Outer Banks. This is a photograph of a barrier island on a plane from Norfolk to New York. I think it's closer to New Jersey. And we are a lot less developed than this, but it also gives you a sense. I mean, it's always incredible to me to see an aerial view of this and realize how fragile these systems are and how beautiful at the same time, and how connected we are to the coastal ecosystems around us in many ways. But at the same time, living on these islands, we are no one here is a stranger to coastal hazards. And these hazards affect hundreds of millions of people worldwide. We saw Hurricane Ian making landfall twice in Florida, in the Keys, and then on the mainland in the Southwest, and then turning back around to make landfall again. And Hurricane Ian damage in Florida was devastating, and this was something. Florida is another place that's constantly hit by hurricanes and storms, and so this really is a very relevant and pressing issue for a lot of us. And at the same time, we're seeing that all along US coastlines, the frequency at which flooding occurs is increasing as well. We're noticing it in our daily lives, but we're also noticing it in the data that we're measuring from tidal gauges around the US coastline. And it's not just the hazards from these extreme storm and cyclone events. There's this rising new threat called nuisance flooding. I'm sure some of you at least would have heard of that term. It's essentially what happens, where you see your high tides coming on to your coastlines where you normally wouldn't expect them. So suddenly your coastal roads are flooded, your parking lots are flooded, you can't get to work. And that's an increasing hazard as well that is starting to affect the daily lives of coastal communities. And all of these coastal hazards, so the storms and the flooding that you get from the storms, your nuisance flooding that's driven from basically extremely high tides, all of that, when your local sea levels rise, all of that are going to rise with them. And we expect to see our sea levels continue to rise, even if they continue to rise at a sort of the rate they're doing right now. We still expect more than 2 feet of sea level rise by 2100. 2100 seems far away, but even incremental inches of sea level can add to that storm surge flooding that occurs and to the damage that occurs. And this poses a risk to all coastal geographies, of course. I just want to focus here. Here it says urban atoll islands, but it is equally relevant to barrier islands. And you essentially see that there is an increase in the risk as the expected sea level rise goes up. But you also see in this bar on the right, essentially what's happening here is that some of that risk can be reduced if we adapt. And so that's Basically, if we say that we are going to somehow protect our shorelines and reduce the amount of flooding that is going to affect us. If we do that, if we invest in that upfront, then we're going to save in terms of the damages that would occur from all of this flooding. So it's not just sea level rise, of course. I mean, you can only have damages and risk when you have something there to be damaged. Coastal hazards definitely go hand in hand with development. This is a picture of Miami in 1925 contrasted to 2017. There is a lot more in harm's way. And this was when Hurricane Irma was threatening to make landfall. Nobody quite knew exactly what track it would take, and it looked like it would head straight for Miami. But this is where we are building in these areas, and by building in these areas, we're putting ourselves in harm's way. But we're doing this sort of consciously and for various reasons, because we like living on the coastline. We like all the other amenities that it has to offer. And it's just a reminder that it's not just what the sea levels are doing, it's also what we are doing. And so the question is, how do we prepare for the next big hurricane? How do we make sure that when a hurricane comes, and I'm not talking just about short-term preparedness and evacuation and all of that, I'm talking more about how do we, as a city, community, town, state, country, how do we make sure that the damages from that hurricane are to a level that we can accept and to a level that we can recover and rebuild from easily. This again here is a picture of Hurricane Ian and a picture of the damage that it did in Volusia County in Florida. So this is not new. I mean, we have been living near shorelines forever. We've been building seawalls since the time of the ancient Romans. So this is not new to us. We have different strategies in what I like to call our adaptation toolkit to make sure that we are prepared. One of them is sort of not really a strategy. One of them is doing nothing. That's not quite an option. We just keep that as sort of our baseline. So whenever we're trying to measure the costs and benefits of an option, we need a baseline, and we say, okay, our baseline is doing nothing, let's status quo. The other one that we're all most familiar with is protection, in that we build structures, usually concrete cement structures, that just stop the water from coming in. We can also, as we have here on the Outer Banks, build our homes, elevate our homes, build them on piles and stills. And this is sort of allows a little bit of that water to flow in and out in extreme cases, and we're kind of accommodating that hazard. We can also go extreme and advance. Like many atoll island countries like the Maldives, for example, are doing, we can dump sand in the ocean, build it up, and then build on top of that and build higher. Now that's really expensive. That's not something that's possible everywhere, and that's also not something that every society or every coastal community would even want. The other sort of end of the spectrum from that is that we move away, we retreat. We go back to higher ground, or we go to a completely different place. Again, an extreme solution in many ways that a lot of us would not be comfortable with, because we are on the coast, because we have an attachment to the coast, and it's not easy for us to just say, okay, I'm going to move away from the shoreline because there's flooding. So these are all sort of adaptation strategies that we're familiar with, and one that is new and sort of just gaining attention in the last couple of decades is what we call ecosystem-based or nature-based adaptation. And the idea here is it's similar to protection, but basically saying if we have an area of natural coastal ecosystems in front of us that could help us by reducing water levels for us, how does that work? I mean, does it work everywhere? And also, what does that mean in terms of our adaptation strategies? And one motivation for this is also the parallel situation that we are faced with our coastal ecosystems, where we want to keep our coastal ecosystems in place. They're being threatened by several human or natural stressors, but we want to make sure that they're there because, again, like we enjoy the coast, we also enjoy the coastal ecosystems that we have around us. So I like to think of ecosystems as what I call natural fortifications against hazards. We just got a new fortified roof for which we got a grant from an insurance agency, and the basic logic of that was you strengthen your roof against hurricanes, you're going to reduce our potential payouts, and so we're going to give you a premium reduction if you do that. And that is kind of an analogous situation to, say, coastal ecosystems where they work. So if we can keep our coastal ecosystems or restore them, and they reduce damages to us, then there is some sort of economic sense in doing that. And so I'm going to just walk through a few different case studies of how this works. One of them is and I'll start with a study in Florida and then move to a study in the North Atlantic, and then finally a study in the Pacific Islands. And all of this essentially is going to be looking at this panel on top here shows a high hurricane or storm event that's approaching the shoreline. You have mangroves or marsh wetlands here, and you have people and their fishing boats and their houses and their buildings behind it. And with the mangroves in place, they see a little bit of flooding, but not much. If these ecosystems were not there, the flooding would be a lot more. And all these people and their property and their assets would be damaged, would be affected. So essentially, the difference in the damages here is the value of these ecosystems for flood protection, for protecting our communities. And that is basically what I'm going to be, for each of these case studies, going to be measuring that in different ways using engineering tools and models. So I want to start off with the role of mangrove ecosystems in Florida during hurricanes. So one study that we looked at was when Hurricane Irma happened. It caused about almost $5.5 billion in storm surge damages, and we find using our engineering tools and models that around 700 million of that, 700 million of that was avoided by mangroves in Florida being where they are. So essentially, these green areas here on this map protected areas behind them. But you also notice here, so what this map is showing is this southern Florida, you have the green areas in the mangroves, and you have these dots that are in different colors. Essentially, if it's red or yellow, it means it's being protected by the mangroves. But what's interesting here is you also have certain blue areas, which means that the mangroves, by being there, were actually increasing damages. And this is what comes out in our models and tools. And so we were wondering what was going on there, so we looked into it. And essentially what's happening is you have certain situations where your mangroves are acting as a barrier. You have a big wave coming in or a storm surge coming in, and the mangroves are slowing that water down, so whatever is behind the mangroves is being protected, but in front, you're seeing a pileup of your water levels. And in situations where we have built out in front of the mangroves, or say within the mangroves where water is being pushed away, we're actually seeing higher levels because of these ecosystems. And so overall, the net benefit of the mangroves in southern Florida is hugely positive. This billion includes all of those negative values. But it is very important for us to be aware of how these hazards interact with our ecosystems when we build and when we live around them. Simply because they are acting as semi-permeable barriers all the time, naturally that's what they do. And so understanding that is very important when we try and understand how to use these ecosystems as adaptation strategies. We find a similar result. We look specifically at Collier County in southwest Florida, where Hurricane Irma made landfall, and then Ian made landfall just north of Collier County. And we do this not just for one storm, because every storm is very different. Hurricane Irma looked very different from Hurricane Ian. Nicole looked very different from Florence. So we do this over a set of 100 storms to try and get a general picture of what happens every year with these properties. And we find very similar results. We find that whatever is behind the mangroves is really well protected in red and yellow, but whatever is built out in front of the mangroves or sort of within them, the results are more mixed, and you still see some damages because of the mangroves as well. And so, again, generally speaking, the effect of the mangroves in Collier County against storms, hugely positive in terms of reducing flood damages, but we need to be aware that it's not everywhere. this figure on the right, it basically shows that as our storms increase in intensity, which is the x-axis, storms are going up in intensity, the benefits of the mangroves sort of cumulatively start decreasing. So essentially what we're showing here is most of our benefits occur, most of the benefits of the mangroves in reducing damages from flooding happen for our more frequent storms that are sort of less intense, not these one-off, 1 in 500 year, 1 in 1,000 year storms. Most of them are for the smaller storms that occur more frequently. Say 50% of the total benefits for Collier County were for storms that occur within a mortgage period of 30 years, for example. And so there again there's an economic analysis to be made here about when we talk about using these ecosystems, what kind of risks are we talking about in terms of what they will protect us against. I also, before I did this work, I also looked at the role of marsh wetlands during Hurricane Sandy. And Hurricane Sandy made landfall in New Jersey. It was devastating for that region, and it was devastating before that when it went through the Caribbean. It caused over $70 billion in damages, and it was a very unique hurricane for many reasons. So what we looked at was similar to mangroves. How did salt marsh wetlands along the coast of the 12 states that Hurricane Sandy affected, how did salt marsh wetlands help reduce damages from this hurricane? So we find that along these states, the presence of wetlands reduced flood damages by around 600 odd million US dollars. Now, this is very small compared to the total damages from Hurricane Sandy, right? Hurricane Sandy caused about $70 billion in damages. Here we're talking an order of magnitude lower. But these savings are very important for the communities that receive them. And this was over about 10 to 20% savings for these communities where they had wetlands. And another interesting thing that we found in this figure on the right was you see the wetlands in green, and you see this darker township here. I think it's Hamilton Township in New Jersey that receives greater benefits than this one here. And essentially what's happening is as the storm surge propagated through, these wetlands further downstream were blocking the storm surge, and this township received a lot of benefits even though it doesn't have many wetlands within it. And so the point here is that the way these natural ecosystems work, the way nature works, it is not our administrative boundaries. So when we are talking about ecosystems and the role they play in reducing flooding, it automatically forces us to look beyond just our boundaries, whether it's our home or whether it's our, and understand the landscape in which they sit and what the effect of those ecosystems are on the landscape. So those are two studies where I used engineering models and combined them with economic data sets to try and figure out, where do wetlands reduce damages. But there's another really important question, which is, do coastal communities want these natural defenses? Like, what are the sort of factors that decide whether we implement a nature-based solution, a mangrove wetland or marsh restoration project or not? And this was work that we did looking across Pacific Island nations, so coastal communities living in Pacific Island nations who are almost every day at risk of flooding. And we collected data from the Philippines, Papua New Guinea, Fiji, and the Solomon Islands, essentially asking communities in each of these places, what are your hazards, coastal hazards? What are the assets that are most important to you that you want to protect from these hazards? And how do you go about protecting these assets? Like, what measures do you take of the range of measures that we have available? And so first we find that as soon as you zoom down to the local scale, as we can see here as well, it's complex. Our problems, coastal hazard problems, get very complex. We're not just talking about coastal flooding from storms anymore. We're talking, in these island communities, we're talking about coastal erosion, wave impacts, we're talking about salinity intrusion. They have freshwater lenses on the beach that are the main source of drinking water, but rising sea levels or high waves during a storm push salt water into that, and that results in their freshwater sources getting polluted. Sorry. We also see, for example, they have, again, they had in many of these, this picture here on the bottom left shows a cemetery. So many of these coastal communities in Papua New Guinea, for example, have very strong place attachment. They've been there for thousands of years. And they believe that when you die, you should be buried close to the ocean. And these cemeteries are being washed away by erosion. And so that is something that is very important, that requires immediate attention and is not something that can wait. And so these problems become very complex when we get down to the local scale. And therefore, so do the solutions. So we find here that amongst the preferred responses, most communities wanted to build structures. Many of them, surprisingly, wanted to use ecosystem-based measures. Fewer number wanted to say, let's raise our houses, let's raise our floors, and very few wanted to leave or reclaim more land. Reclaiming more land, of course, is very expensive, very difficult to do. Leaving is the other extreme. It's difficult to do, especially when you have such strong place attachment. And structures, interestingly, most of them wanted structures because most of these problems were immediate, and structures have been put in place earlier that have, when they work well, they work really well. But the problem is, it's not easy to put in big seawalls, big bulkheads, or big gabion baskets that work well all the time. Often what even these communities have seen is that a seawall or a bulkhead is put in, it fails, it's a waste of money, it's a waste of effort, and it doesn't do anything. But on the other hand, they have been working with their ecosystems for, again, hundreds of years, if not more, and they know how to restore mangroves, they know how to restore their coral reefs. And so that is one solution that they can actually work with quite easily. And at the same time, it helps them preserve their coastal environment because they are ocean-going people. Without your coastal ecosystems, you're not going to have fish. You're not going to have the aesthetics that you enjoy. And so working with these ecosystems for coastal flood reduction also helps them preserve them. Because they also realize, and it's also known, that when you build too many hard structures, you're starting to disrupt the flow of water and also damage these ecosystems. So what we see here, because of that, is when it comes to implementation, structures sort of tend to go down, ecosystem-based measures tend to go up, especially structures that are modern, and what we mean is cement and concrete and technical engineering expertise. Traditional structures, for example, simpler sort of fences built out of mangrove wood are more easy to implement again, and people are more willing to do that. And all of that then results in this trade-off here where you have easy implementation on the right, but then very high effectiveness on top here. And so you sort of see that a compromise is needed here. I mean, it's extremely effective to fully relocate, but that's not at all easy to implement. And also bear in mind here that we're talking only about coastal hazards. You may be relocating to the mountains and realize you have an entire different set of hazards when you relocate there. So that's not the entire picture as well. The other thing that we look at is the cost. So far we've been looking at the benefits, and now we want to turn to the cost, because if you're talking about economics, you always want to have a benefit to cost ratio that's greater than 1. You never want to be putting money in when you're not getting a return out of it. And so here we looked at the costs example for building a breakwater, restoring a mangrove forest that provides the same benefits, and restoring a salt marsh wetland that provides the same benefits as that breakwater. So they all provide the same benefits. What do they cost? And we do find that a breakwater costs a lot more than the wetlands and the mangroves. But these are not cost-free. There is sometimes a notion that because we're working with nature, it's all cost-free and it's just going to do its thing without us having to worry about it at all. That's not true. We're going to have to, when we restore, we're going to have to get permits. We're going to have to figure out what the sediments are doing. We're going to have to do that properly. And then when something gets damaged in a storm, like a mangrove forest, we're going to have to go back and repair it like we would repair a hard structure as well. So there are a lot of costs associated. They're just much lower per meter of coastline than, say, a breakwater or a seawall. So these are all the various aspects of coastal ecosystems that we look at in the research that we do. I also want to sort of just give you a brief overview of different kinds of projects, funded projects that we have ongoing in our lab that look at various aspects of this. One of them is financing the restoration for coastal protection. So essentially the idea being, if I were to restore, say, 100 hectares of marsh wetland, and I can prove through a certified process that that marsh restoration is going to save $100,000, then I can go to someone and say, could you give me some of that money, of that $100,000, so that I can restore this wetland? And so it's a sort of a credit system for coastal protection. We're working on that now. It gets very complicated when you try and start making this a standard method that can be certified and all of that, so it's a totally different world. We're still a ways away from that, but we're getting there slowly. The other thing that we're doing here in North Carolina now is working with a colleague here at ECU, Dr. Gitman, and a graduate student of ours, Georgette. So looking at oyster reefs and how oyster reefs can help reduce erosion and also reduce wakes from boats. So you often have oyster reefs lining shorelines where you have a lot of boating. When you have boating, you have wakes, and when you have wakes, you have erosion. So can these oyster reefs function as sort of wave attenuators to reduce some of that erosion? And then what is the engineering and ecology related to this? We're also looking similarly at assessing salt marsh benefits in urban floodplains, specifically in Houston and Galveston Bay, where we're looking at Hurricane Ike, and as Hurricane Ike went through, but also trying to tie this with development. So if Hurricane Ike occurred in 2008, in 2019, it would have been a very different story with a lot more value in that floodplain. So how does that look in terms of the benefits that these communities receive from the salt marsh wetlands within Galveston? And we again find similar patterns here. We see that most of the wetlands reduce flooding, but some of them increase flooding, especially the ones that are right out, for areas that are right out in front. And finally, this is a new project that we'll just be starting, is the feedback between humans and natural systems. So these are coastal ecosystems. They're interacting with hazards, and they're helping protect us in most situations, not in every situation. But on the other hand, we are also managing these ecosystems. We're using these ecosystems. Sometimes we're extracting from them. We're taking mangrove for timber or firewood, or we're cutting seagrass or harvesting oyster. And so there is a feedback here between what we do to the ecosystems, what the ecosystems do for us. And so trying to understand, parse out all of that. We're going to start a project soon, again here with co-PIs Nadine Heck and David Lagomasino at ECU, who are also both in the room. Yeah, and others in Fiji and Puerto Rico. So it's a large project, and hopefully we'll find something interesting from it. So just 3 takeaways at the end of this, for you to remember to take back home on your ride, is that coastal ecosystems are vital to our way of life, but they're also vital to our security and coastal protection. It is important to understand where and how these ecosystems are helping to protect lives and property from coastal hazards. And it's also important to understand how these ecosystems interact with the hazards and also interact with humans and the way we manage them. Thank you. Yeah, happy to take questions, and while we have questions, I'll just be playing. These are 2 videos here of Hurricane Ike. The one on the left is wind speed, and you can see Hurricane Ike coming through in our computer models, and the one on the right is flooding as Hurricane Ike approaches.
And so just as a reminder, we are also streaming this live, and so if you have a question, we'd like to get you a mic so those that are online can also hear that. So questions?
You said that you studied in the Netherlands.
Yes.
We were there last spring, and we asked our guide about what what are they doing if the water rises? They've been dealing with this for hundreds of years. What did you learn there that might help, let's say, in the Outer Banks?
I learned a lot in the Netherlands. They really are, because of that history that you mentioned, they really are at the forefront of understanding flooding and how to deal with flooding. So they had, I think, one of the most historic, like sort of game-changing floods was the 1953 flood that occurred in the North Sea, and it wiped out a lot of the Netherlands, people, property, livestock. And in response to that, they really learned how to build barriers. So they basically cut short their entire coastline, built storm surge barriers, huge levees, and they're starting to go the other way now because they've sort of realized that after having built all of these barriers, what they've done is completely cut off tidal exchange and completely change what's going on inside in the areas that have now been closed off. And so now, even in the Netherlands, it's sort of shifting to how can we do this, but in a way that's a little bit more, it's no longer a battle with the ocean, it's a little more, let's figure out how to work with it. So I learned the engineering side of how to build really good barriers, and then I learned this side of, okay, we need to think about whether we really want these giant storm surge barriers everywhere.
Yeah, he said they have ways of letting water actually come in, but then it can go out also.
Yes, they have systems that allow that you can essentially, you have like underwater gates that can rise and close and all sorts of complex engineering. It's fascinating, really, yes.
Thank you.
Yeah.
Thank you very much. As a stakeholder with experience with Katrina, Sandy, and the storms here, 15 years in the Outer Banks, it seems to this resident that the biggest obstacle we face, your research is wonderful, is with our governments. We have flood maps coming out of the federal system that make no sense whatsoever. We have local governments allowing development that makes no sense whatsoever. How, as stakeholders, can we help you get the good word to our government partners?
Oof. Yes, I agree. We're trying as well. I mean, there's a lot of work being done on FEMA flood maps and just how misplaced they can be. But I think the good news is that agencies, at least, are really starting to also, just like in the Netherlands, there's now starting to be a change in conversation. Like FEMA is now realizing that their flood maps need to be updated and using much better models, for example. And the Army Corps of Engineers, who traditionally, typically were not known for sort of being gentle with the way they do things, are also starting to look at how do we work with communities to figure out solutions that essentially, where we can build something that we want to build, but then it's not having all these ridiculous effects on the people there. So there is a small, slow change that's happening. What you can do as stakeholders, I mean, I guess whenever there's a public forum or opportunity for public comment on this is to just give them your experience and tell them this is what I see going wrong. I don't see, yeah. Or run for office.
We have also been to the Netherlands, and one of the things that the Netherlands does very well is when they have a fatal storm, they fix it, and they go with the more expensive solution because if it happens again, they're going to spend that money anyway. So I'm wondering, in your analysis for building some of the walls and building some of the barriers that are very complicated indeed, as we know from Venice, they are very costly, but they work. What is their rate of success to justify that cost, and is that cost justified at all?
Thank you. That's a great question. And you raise a great point. I think what we're finding and what we see around the world is that these costly barriers have their role and their function. So for example, the Thames Barrier in England. is a really costly barrier that nobody really knows about because it's worked so well. And it's sort of that engineering, it's like that engineering thing. You don't notice the bridge if it's working well. And it's sort of, these expensive barriers tend to be really cost effective in areas where you have high density populations, really high value assets. But once you move away from those places, and the Netherlands is a very small country that's very sort of, it's much more uniform in terms of where population and wealth are distributed. But even in the Netherlands, they're having this conversation of, for example, what they call acceptable risk. And so you have areas where the levees are lower than in other areas in terms of what they'll protect against. And they're simply making a calculation of what's behind it that we want to protect, how much are we willing, to what extent are we willing to protect that in terms of money, and what does that mean in terms of what we can build? Because we cannot be defending every coastline, say, for example, against a tsunami that might happen once in 1,000 years. We're making those decisions already. So I think it's just being a little bit more thoughtful and sort of having a framework in which we make those decisions looking 15, 20, 30 years forward.
Hey, Sid, if I could just interject real fast, because thinking of the question asked, and particularly thinking about the recent public forum down in Rodanthe, I mean, and tell me if I'm wrong, but sort of hardened structures as it's being sort of inferred here is likely not talking about what's happening on our estuarine shoreline, but thinking what's happening on the front line, right, on the Atlantic shoreline. And I wonder if you want to speak to what hasn't worked when trying to really create these large barriers and expensive on the front side of a barrier like this.
I think the main thing there in creating these barriers is we are completely changing the morphology and the tidal exchange that we're going to get behind that. It is going to completely change the character of what's behind that. And if we want to keep what's behind that, those ecosystems, those tidal exchanges, those fish, our access to the ocean, all of that is going to be influenced by that. So that counts, yeah. Yeah.
Someone back to the microphone first.
Yeah, I've got a question. Floodplain maps are based on elevation, and some of the graphs that you were showing of southern Florida and Hurricane Sandy, have you compared areas behind salt marshes with what would normally you might expect just from change in elevation? Did those graphs or presentations take that into account?
Yes. So our models take elevation into account. Elevation is the most critical factor in determining what your damages are. That's number one. So essentially what our models are doing is we have a bathymetry map. So we have our elevation map. We have our vegetation. We have the property wherever they are on that bathymetry. The storm surge comes through, we see what the flooding is, and the only thing we do is just remove the vegetation and then run the storm surge again. So it's for that same, it is counting for the bathymetry effects, yes. But that is the most important criterion, yeah. Sorry, I'm losing track of the order thing in front here and then to
the front end, the Atlantic. So we're doing a lot of beach nourishment year after year after year. And my question is, instead of building a barrier, has there been a study of building at least an partial artificial reefs off the coast, off the shore, that would dampen some of the energy that would at least allow a lot of that sand to remain versus huge waves, displacing the sand back out into the ocean?
Yeah. Artificial reefs in this region, not so much. It is just going to be a breakwater reef because the other thing with these ecosystem-based solutions is that ecosystem, a precondition for that to work is that ecosystem needs to be able to survive and thrive in that climate. And so, for example, if we definitely can't put reefs out in front that are oyster reefs, or we cannot put coral reefs here. They're not going to survive. And we can't put in, say, oyster reefs because it's just too high energy waves. And so in that case, what we're left with is breakwaters. So essentially just mounds of rock and breakwaters. Now, breakwaters are effective. They are effective in reducing waves, in making sure that your beach builds up behind them. The downside of breakwaters is that it is, again, something that's quite difficult and expensive to build, and we need to have a thorough analysis of how it's going to modify our sediment transport. Because if we put in a breakwater incorrectly, we might end up losing a beach. And when the beach is our economy, then that sort of becomes a little tough to. Yeah. It needs careful thought, but breakwaters are definitely a solution.
Well, just to follow up on that, so you're saying that here on the Outer Banks, our solution or one of the possible solutions for the ocean is a breakwater system. And I know right now we have the beach replenishment, and on the sound side, we have the oysters.
Yes.
And what are we looking at for future?
That's a tough one, because breakwaters on the ocean side, again, it's going to be very limited in terms of what you are protecting, right? Like, it's going to be prohibitively expensive to put in a breakwater all along our Outer Banks beaches. Beach nourishment is something that's a little bit more sustainable in that we can keep carrying it along, and it's widening our beaches, and we have that added amenity as well. So breakwaters are technically possible. Whether they are practical is an entirely different question, and I doubt that they'll be practical here unless you have a very localized, very specific problem that you want to solve. And the other thing in the Netherlands that they've done now, in talking of beach nourishment, is they've experimented with what they call the sand engine, where they have a giant amount of sand that they've mined and spread out along their central beaches. The idea being it's a huge nourishment project that's dumped in one place, and the idea being that the waves will work that sediment down the rest of the coastline and keep the beaches wide for the next, I think, 50 years or something like that. So essentially they're saying what we would do every 10 years for the next 50 years, let's just do it all at once, but design it really carefully, do it now, and then for the next 50 years, we don't need to do anything. So that's sort of another extreme engineering example, but working with sand.
I think you just sort of got into it, but this isn't so much a question as an observation. I'm from Kerala, and our revenue comes from tourism. And one thing that I don't think we've talked about is aesthetics, and what are our visitors going to tolerate in terms of going down to the beach and seeing those kinds of things. And I guess they're solvable, and I'm not siding with our government, but there seems to be a lot of resistance in Currituck County to really address the problem. And I think they are worried about, our visitors, if they see barriers and not marsh plants, but plants and things, are they really going to be attracted to our beaches? And I don't know if that's something that's being considered in all of the possible solutions, or the aesthetics of the beach, and a lot of water sports on the beach as well.
Yeah, I think the marsh plants is more sort of sound side, estuarine type of solution. And it's just, open ocean, the only thing really would be, for example, where you have coral reefs, where you can restore healthy coral reefs. They are very effective in reducing waves. They're not as effective when a storm or a storm surge comes along, but they're very effective in reducing your daily waves, high waves, and keeping your beaches healthy. But marsh plants are going to be more of an estuarine. Yeah.
Yes, thank you. I had a question about the salt marsh. Kind of in our backyard, we're not really paying more attention to the Nutra. I think everyone know about them, but there really doesn't seem to be anybody doing anything about them or the discussion happening. Unfortunately, there's a picture in the hallway of one. We had a discussion on the way in. It's actually happening in my backyard and everyone's backyard. So how do we deal with that, solve that problem, which has been an invasive problem for the East Coast and the South for a long time? And how do we replace? Are we replacing the salt marsh, the black needle rush, the everything? How are we pushing them back? Are you studying that? And how are we replacing it?
As an engineer, I would say I know nothing about that.
I was going to say, you're asking an engineer how to get rid of nutria.
but that's a good point, right? It's precisely, you have, again, you build a seawall and you sort of say, okay, I have built the seawall, I know what material's gone into it, and I can roughly expect until when it'll last. But if you're working with ecosystems, then we have to accept that they're dynamic and that there's various factors that are changing them and influencing their health as well. So it really needs us to be a lot more nimble in the way we manage the ecosystems, and also forces us to be interdisciplinary, which is sort of the focus of what we're doing here at CSI, is really working. I cannot be, like, as an engineer who says, oh, let's work with ecosystems, I cannot not work with an ecologist or a human dimensions person to understand what those interactions are.
Well, I guess that's my question too. You can plant the mangrove, can you plant the salt marsh? Are we doing that? Are we looking at that, doing that?
Oh, there's like decades of work done on salt marsh restoration that I know of, but can't really speak to. But there is a lot of expertise and science on restoration and invasive species and all of that, yes, for sure.
So I've got a two-part question online. The second part I'll ask first because it kind of relates. Have you looked at any wetland restoration or estuarine restoration in your research?
I have looked at some specifically for mangrove restoration, but I have only looked at it in terms of where did this restoration occur, what did it cost, and if I put that restoration project into my models, what would the benefits be for flood protection? That was sort of the limit to which I looked at restoration per se. But the project I mentioned where we're trying to figure out how to finance wetland restoration for credits is essentially looking at that.
And then the first part of that question was, can you share how you plan on sharing your research, and how are you making sure that people know about the critical role that our ecosystems and their role in protecting communities work?
Yeah, sure, by doing things like this. Yes, yeah, and also whenever we work with NGOs or governments, we usually have policy briefs or fact sheets or reports that we produce that are essentially the same science, but in a more accessible way. Yeah.
Many communities in Florida are actually bolstering their zoning and building regulations. Apocryphally, I've heard that they are useful in keeping the damage down. Do you have a more quantitative assessment of how effective these measures are? Because you would think that insurance companies would just love that, because it doesn't rely on the government and relies on individuals to do their rebuilding in a way that's more robust. So what can you say about that?
I have not looked at this specific topic myself, but zoning and regulation are critical to reducing risks. I guess that there is also a sort of, I guess the tension there is with, business and business interests, and how do you keep the economy of a place going if you're not going to let people build over there. So that's sort of a trade-off. I haven't looked into the specifics of Florida's rezoning, and it's like quantitatively measure its effects. There have been studies that have shown, for example, that if you, in areas where you have land that's not being used or land that's been left free, generally speaking, in those areas, you see lower applications for FEMA insurance payout permits. So that's one way people look at it, is like, okay, a hurricane struck, like say Katrina or Irma, where did people apply for permits? What was the land use that was going on in that region? And so that's sort of teases that out. Yeah.
Other questions?
That's one of them.
I could just comment on that gentleman's question. I'm an engineer. I have offices in Florida. After the disaster of a year ago, the entire building codes down there are being looked at very, very seriously and substantially upgraded.
Thank you.
I appreciate that. Yeah, our answer along the Outer Banks has been the beach nourishment, where we contract with someone to go out, find the borrow pits of sand that would be consistent with the part of the beach that they're filling. Now, it just seems to me that over a period of time, and I don't know what that period is, those borrow pits are no longer going to be there. They're going to be spread out, moved. What then? I mean, has anyone even addressed that issue when they spend the money and they say, yes, we can replenish next year and the year after? But eventually,
That's a sort of,
Mother Nature will have her way.
I feel like that's a sort of don't see, don't know problem kind of, don't see, don't care kind of problem. I mean, it's partly the reason the Dutch did this sand engine approach, that they said we don't want to, we think it's more damaging to keep going every 10 years and doing that dredging and digging up operation than if we just find sand once and then don't touch a place for like 50, 60 years and then let it naturally recover, so that if we go back, there's actually sand available. But yeah, that's definitely an issue.
I'll put a plug in for myself. So a couple Science on the Sounds ago, I gave a presentation focused on nourishment and some of the implications associated with nourishment. In that presentation was a map of many of the borrow sites. So there has been a lot of mapping off of our coast that does sort of show where we have potentially compatible sand for nourishment. The Outer Banks are actually, fairly blessed with sand compared to places along the North Carolina coast just to our south. And I think there are questions that you can raise about whether some of these resources that you have, sand resources that you have offshore, whether you would want to use those, Wimble Shoals, Platte Shoals, these areas that also could be important breeding grounds for important recreational and commercial fish. And so there's questions you can raise about that, but when it comes to sand resources, again, the Outer Banks do have quite available. How long, right? That's a question that would require more research to see the compatibility and get a bit more understanding of the depth of those resources. But I think in the near term, actually, the Outer Banks are doing fine, particularly when we compare to Wilmington, Topsail, and some other locations. But it's a question that has to be considered. I don't mean to interrupt.
No, I should have. I should have given you the plug.
Do you know the cost-benefit ratio approximately of the renourishment projects that we're doing here on the Outer Banks?
We're still doing them. That tells you something, right? We will, and there's no doubt that we will continue the program, right? It's not a one-off. It is a financial decision that is run through a financial model. And the towns work with the county to look through those financials to see if it is still a viable way of moving forward. And it is. Again, the beaches are a significant resource for us because of the draw that it has, and therefore the resource that the county and the towns get associated with that. And so economically, it still works. One day, the economics won't work, right? No doubt, one day the economics won't work. But it's not today. I don't want to have the last word.
I think it's a good note to stop on.
Other questions? Blagamasino. Final question.
So Sid, you talked a lot about the human barriers that we're putting out there. We talked about the natural barriers, right? Those ecosystem-based adaptations. Is there a way forward that is the best of both worlds, right? Both of those things working together, both concrete infrastructure and nature-based solutions?
Yeah, thanks, David. There is this sort of mix and match that we call hybrid living shorelines, where these are sort of small scales at your home, at the scale of an individual home or a couple of homes, where you combine, say, a very small breakwater with a marsh behind it, and the breakwater is functioning to keep the marsh healthy, and the marsh is functioning to keep whatever is behind it healthy. So I think that is probably where we'll see a lot of these hybrid solutions, where concrete is working together with the natural elements. Yeah.
All right, let's thank our speaker.
Thank you.
Again, I appreciate you coming this evening. I think these conversations are exactly what we need to have, right? I mean, we are challenged moving forward. There's no doubt there are complicated things that we need to start talking about. It's these conversations, right? What can we do? We can certainly educate ourselves. We can try to educate those that are making the rules for us. This is the first step. So again, thank you for taking the time to come out. Thank you, Sid, for the presentation, and thank you for all the questions. Hope you have a good night.
Thank you, everybody.
I'm a Hokie, and I'm glad to see you have VT people involved in your project. So you got some real talent here.